Hello, now I'm going to discuss programmable array logic for the particular function. That function having mean terms 0, 1, 2, 4, and other functions having mean terms 0, 5, 6, 7. So these are the very important questions for the examination point of view. So here you know that in case of programmable array logic, if you're able to recall their block diagram, then if you see that here we have programmable and array. Whereas next one, if you see, this one is the fixed or array. So what is the specific about this? So here like we have input and from here we are going to get the output. So here in this, if you see that AND array is programmable, whereas OR array is fixed one, and here product terms will not be shared with another function. So that we have to keep in mind. And in case of PAL, when you will get the question, there you will not have any restriction that you have to implement by using 4 product terms or by using 3 product terms. So here first we'll go for the K-map. So we'll go for the K-map of the function F1. So this K-map is for F1. So here given midterms, if you see that 0, so here we'll write 1. Next we have 1, so that again 1. And midterm is 2, that we are going to write here 1. And last midterm is what here 4. So now you have to make the combination here. As you know from the K-map, here if possible of quad, we can do the quad, but quad is not possible. So we'll look here for the pair. We'll make the pair of midterm 0 and 4. So if you see that what we are going to get here, row wise, nothing is common. Column wise, we have B dash, C dash. Similarly, we have to take the another combination. In that combination, if you see that, if you make the pair of mean term 0 and 1, then again here row wise common is what here? A dash. And column wise, what we have common? That is the B dash. So here we have product term A dash, B dash. One more term, mean term 2 is uncovered. So that you are going to make here again pair with mean term 0 and 2. So for this, we'll have product terms. So row wise, common is A dash. Column wise, if you see that here, common is what? C dash. So that's why we'll write A dash, C dash. So finally, if you see that function f1, we can write as A dash, B dash plus B dash, C dash plus A dash, C dash. So now in this function f1, we have 3 product terms. Similarly, we'll see for the function f2 also. So for the function f2, what are the mean terms are given? Again, we have 0, 5, 6, 7. So for that, again, we have to make the combination. So if you look here, what are the combination is possibles? So here, if we include the mean term 5 and 7, so we'll get the one pair here. So for that pair, what we are going to get the equivalent? Row wise common is A. You have to see this row. Row wise common is A, and column wise what we have common? That is the C. So that's why we'll get here AC. Similarly, we'll look for the another combination. So if you see that here 7 and 6, we can make one more pair. So for that, what is the value? Row wise common is A, and if you see the column wise, so that column wise common is here, that is the B. So we'll write this one as the AB. And this mean term 0 is isolated. Here we can't have any combination is possible. So for this, if you see that we have to write row wise, we have A dash, column wise B dash and C dash. So finally, if you see that we got F2 also. So F2 is what? AB plus AC. In these two we have two literals. And third one we have A dash, B dash, C dash. So each having here three product terms. And all product terms are unique also. Anyhow, if it is not unique also, then also we are not going to share the product term with another function. So now we'll try to implement the function f1 as well as f2. So here, how many product terms are there for each function? That much AND gate is required. And how many function we have, that much OR gate is required. So for the function f1, we have three product terms. So we required here three AND gates. For the function f2 also, we required three AND gates. And since we have two functions, so that's why we required two OR gates. For each function, we are going to use one OR gate. So now if you see that here input side, each literals are with complement also and without complement also. So we are going to use here buffer. So if this is the A input here, if you are connecting from here, this is the A without complement. From here we have with complement. So this one is our A. This is going to be the A dash. Similarly, we can look for the B. So again, B is connected. So this is B, this is the B dash. So same thing we can mark here also. This is the B, this is the B dash. Similarly, third one we have C. So from here, if you are taking output, this is C. From here we have C dash. So we can mark here for this purpose again. This is the C and this is the C dash. Now whatever values, whatever product terms are given, what is the literals combination for that product terms? So here we are going to use the logic array symbol. We are not using the conventional symbol. Logic array symbol, in that we have to take the single wire. Now whatever literals are available for the particular product terms, there will put the cross. That cross shows that, this cross shows that fuse is intact. And where we are not putting the cross, so their sign is plus, it will show that fuse is blown. So when fuse is blown means it's going to store the zero state, and fuse is intact means it's going to have state 1. So now first we are trying to implement function f1. So here product term what we have, A dash, B dash. So for that we have to put the cross when we have A dash. Again we have B dash. So for the B dash, again we are putting the cross. So now this fuse is connected. In second product what we have, that is the B dash C dash. So again for the B dash we are putting the cross. Again we have C dash. So for C dash also we are putting the cross. Third product is what? A dash C dash. So for A dash it should be cross here. Again for the C dash it should be cross. So now three product terms of the first function we have implemented. Now we are going to give connection with the OR gate since here plus sign is there. So all product terms are being ORed. So now this is going to be input to the OR gate. Again we have another input, that is the A dash B dash, and third input is here, that is the A dash C dash. So finally this OR gate is going to represent the function f1 which having product terms A dash B dash plus B dash C dash plus A dash C dash. Now we'll look for the function f2. So function f2, again three product terms are there. So first we'll represent the first product term, that is the AB. So we'll put the cross here at A. Again we have put the cross at B. Second product term is what? It is AC. So where we'll connect? At A. Again, we'll connect where? At C. So like this, fuse intact we are showing. And third one we have, that is the A dash, B dash, C dash. So A dash. So here we have fuse intact, A dash, fuse intact at B dash, again fuse intact at C dash. Finally, this all product terms we are going to give input to the OR gates. So like this we are going to connect. Again A dash, B dash, C dash also third product terms we are connecting. So finally we are getting here F2. So this F2 is what? AB plus AC plus A dash, B dash, C dash. Like this we are able to implement given function with the help of program array logics. So now here if you see that at this stage, if you have 3 inputs AND gates or if you have 4 input AND gates, which input we are giving, for that you are putting the fuse intact. Other ports are not open. For that here input is considered as 1. Input as 1 for AND gates which port is not connected. Like suppose this AND gate having 3 ports. So we are connecting only 2. What about third one? So third should be 1. Since in case of AND gate, if all inputs are high, then only one will get the output. That's why input is considered by default as 1 for the which port is open for the AND gates. So in case of programmable array logic, you have to keep in mind that only AND array is programmable and OR array is fixed one, and here product terms will not be shared with any other function. Thank you.